All right, welcome to the end. This is section 12.5, the last section of the course. Woohoo! Look at those circles. Everything is literally coming full circle. All right, we're going to end the chapter by looking at circles in the coordinate plane. So, some of the different things we're going to be doing are writing equations of circles, graphing circles, and looking at some different representations on the coordinate plane that we can do with circles. So first thing, just like when you were in algebra class last year, you learned that the equation of a line could be written in the form y equals mx plus b, or we often looked first semester at looking at the equation of a line in point slope form, which remember was like y minus y1 equals m, which is the slope, times x minus x1. That was the equation of a line with a point on the line of x1, y1, and the slope was m. Well, similar to having equations of lines, we actually have a nice, we call it a standard form for the equation of a circle. And the equation of a circle, in standard form, is given by x minus h squared plus y minus k squared equals r squared. A couple things to notice. We'll dive into what each of these letters represents. First thing, notice that both x and y have terms that are squared, and there's addition between those squared terms. Okay? So that's one thing to notice. The other thing to notice is that the letter r on the right-hand side is pretty much what we've been using the entire chapter for r. R represents the radius. But what you'll notice is that it's the radius squared that's on the right-hand side. So that's going to be what we have to be careful with when we're graphing these circles, or when we're writing the equations, or maybe if they give us the equation and we're asked to identify the radius, realizing that that's actually r squared. So if we needed the radius, we'd have to take the square root before we can actually give that answer. Now, just a couple things, what are all these different pieces? What's h, what's k? We talked about what r is, right? R is the radius. So HK is the center of the circle. Okay. So those are the coordinates of the center. H represents the x-coordinate, K represents the y-coordinate. One thing to notice, though, is that there's a minus sign to the left of H and to the left of K. Kind of similar to when we did point slope form. If you're plotting a positive coordinate, you're going to see a minus sign in the equation, whereas if you're plotting a negative coordinate, you're going to see a plus sign in the equation. This was very, very similar to when we did point slope form. I have a little Desmos I put together. I'm going to show you. Let's see if I can find it. It was here. Where'd it go? Desmos. Okay, well, let me see if I can pull it up real quick. There we go. So what I have here is a lot of, let me see if I can move my, there we go. I have a lot of different equations of circles just so you can see what happens as we start adjusting different values in the equation. So for the first one, just a really, I would say, very simple type of equation where there's no, you'll notice there's no parentheses, there's no pluses or minuses next to x or y. The left-hand side, if you'll notice, is just x squared plus y squared. This is the simplest type of circle where it's centered at the origin. So if I was to look here, the center of that circle is right at 0, 0. And notice on the right-hand side, I have 25. And remember from the standard form, that's my radius squared. So if r squared is 25, my radius should be the square root of 25, which is 5. And if you look at the circle and count from the center at 0, 0, you do have a radius of 5. If I go to the right-hand side, this goes over 1, 2, 3, 4, 5 units. If I go, say, up from 0, 0, it goes up 1, 2, 3, 4, 5 units. Same thing for the left-hand side, 5 units to the left. And then if I go 5 units down, I still reach the circle. So that would be a radius of 5. Now, I'm going to turn the purple one off. I'm going to turn the blue one on, and you'll notice one similarity. Notice that I didn't change the x squared plus y squared. The circle is still centered at 0, 0. What I did change is now it's a 9 instead of a 25. And if you notice, the radius of this circle goes out 3 units to the right, up, down, and to the left. And really, honestly, even if you go on a diagonal, it's still measured 3 units out. It's just harder to count because you can't count the squares. So the radius is 3, and that makes sense because, remember, in the equation, that 9 represents the radius squared. The radius is 3. 3 squared is 9. Okay, so really the only difference between the first two that I plotted, and I'll put them kind of at the same time, those are what we call concentric circles. Looks like a bullseye. They have the same center, but they have a different radius. Now, I'm going to keep the blue one up, and I'm going to have us compare it to the next one here in green. Looks like the size of the circle didn't change, and we can see that because if you look at the right-hand side, both of those values are 9. So the radius of the circle is still the square root of 9, which is 3. What did happen, though, and again, I'm going to turn the green one off for a second. Remember, this was centered at 0, 0. If I turn the green one on now, the center of this circle is at 2, 0. So what that minus 2 is doing is it's moving the location of the center for the x-coordinate 2 units to the right. And remember, it's a little sneaky because there's a minus 2. So you'd first think, wait, minus 2, that's usually negative 2. It should go left. But it's because of that standard form that we were talking about. Because there's a minus sign next to that h value, it's going to do the opposite of what you would expect. If it's a minus, it's going to move it to the right. And if it was a plus, it would move it to the left. So if I go back here, I'm going to do number 4 now. You'll notice in this one, it moved the circle to negative 2, 0. And you'll notice the y-coordinate didn't change. It's still y squared. We're not shifting y up or down at all. It's just basically this is like y minus 0 all squared. And so they don't need to write the minus 0 part. They usually just write y squared. But that plus 2 is really minus negative 2. So it's moving it 2 units to the left. Even though you see a plus sign, it's going to go the opposite direction. Now, if we do the same thing with the y's, let's keep x where it's at. So let's keep x at 0. If we were to turn on number 5 here, okay, think about for a second, what would the radius be? Okay, so radius would be square root of 9, which is 3. I'm going to turn number 5 on. It should be either moving up or down. Remember, it's opposite of what you would expect. Normally you would think minus means down because it's negative, but it's going to go up 2 units. So I would expect the center of this circle to be at 0, 2, which is exactly where the center lies. If I count from 2, I go 3 units up, I'm at 5. I go 3 units to the right, I'm at 3. I go 3 units down, I'm at negative 1. And I go 3 units to the left, and I'm at negative 3. Okay. So definitely pretty cool stuff. Okay, if we go plus 2, you can predict it's going to go down 2 units, opposite of what you would expect. There we go. There's our center at 0, negative 2. Okay, and then now, just to kind of put it all together, what if you wanted to move it left and right? What if the center is in one of the quadrants? Quadrant 1, Quadrant 2, Quadrant 3, or Quadrant 4? Well, in this one, the radius is still going to be 3. Okay, square root of 9, still 3 units, so the radius will be 3. But now the center of the circle is going to move from the origin 2 units to the right, because it's minus 2, and it's going to go 4 units down, since it's plus 4. So the center of the circle, it's going to be the opposite of what you see in the equation. The center of the circle would be at positive 2, and it would be at negative 4 for y. Okay? So it would be down here in quadrant 4. Okay? And I'll even add that point so you can see it. Positive 2, negative 4, right there. Okay? So again, biggest takeaway here, you have to switch the sign from the equation. If you see a minus 2 here, the center is going to be at positive 2. If you see a positive 4 here, the center is going to be at negative 4 for y. And the last thing to remember is that the radius has to be squared in the equation. So if the radius here is 3, the equation needs 3 squared, which is 9. And vice versa. If they give you the equation, you need the radius. Square root of 9 would be 3. You have to take the square root. Okay. So it gives us a little background. Now let's kind of go back and take a look at some of the examples here. Okay. Re-rotate my screen. Okay, and then last thing in the equation is that, let's see here. Last thing in the equation, so HK represents the center of the circle. So I'm going to put that in green. That's the center. Okay. What XY represents, and you're not going to have numbers plugged in for X and Y when you write the equation. XY just represents any point on the circumference of the circle. So any point on the blue round part just represents points on the circle. And again, when we say on the circle, we mean on the circumference, on the round part. Okay. And that'll be useful for us when we have to, start doing some of the problems. Is they might give us a point that lies on the circle, and that can help us identify the radius if we were to plug in that XY ordered pair. Okay. So HK is the center. XY just represents any point on this circumference that I'm outlining. I'd say I made a somewhat decent circle, not too great. Okay, so some examples. Identify the center and the radius. Remember, we got to switch the signs. So if I see +2 here, I know that my center for X is going to be -2. And if I see -3 next to Y, I know that it's actually going to go up 3 units. So this is going 2 to the left, and it's going 3 units up. So -2, +3. So the center will be in quadrant 2 in the top left corner. And the radius, don't fall for it, the radius is not 49, that's r squared. If r squared is 49, we have to take the square root. The radius of the circle would be 7. Okay. Number 2, I don't see any parentheses for X or Y, which means it's just centered at 0, 0. You can almost think of this as like X minus 0 squared plus Y minus 0 squared equals 80. They're typically never going to write X minus 0 because X minus 0 is just X. Same thing for Y. Okay, so if you don't see parentheses, the center, nice and simple, is right at the origin at 0, 0. The radius for this one, remember this is r squared. Well, if r squared is 80, and we square root both sides, 80 is not a perfect square. So we're going to put this one in simplest radical form. Okay, if we break down 80, biggest perfect square that goes into 80 would be 16. 16 times 5. So I'm going to do root 16 times root 5. Square root of 16 comes out of the radical as a 4. And 5 cannot break down further since that's prime. So my radius of this circle would be 4 rad 5. I won't make you graph ones that have messy radii like that, because 4 rad 5 is a decimal, right? This would be like, the radius of that circle would be about 8.9, so not quite 9 units. So if you were doing this by hand, you'd have to estimate, but not every circle has a whole number radius. This is a good example to see that. Okay. So sometimes they'll give you the equation and ask you to find the pieces. Other times they might give you the given information. They might tell you where the center is. They'll give you H and K, and they'll give you the radius of the circle, and you can write the equation. So they're giving us H and K. They're giving us the radius is 6. We're going to write the equation of the circle. I always set up my template kind of like this. I know it's going to have to be x squared, and I know there's going to be a y squared. I'm going to erase this part so it doesn't get in the way. And I know that on the right side, I need to have the radius squared. So this is kind of like my little template. So on the right side, I usually do that first because that's the easiest part. The radius is 6. We need r squared. 6 squared would be 36. So there's my right side. And then when you're doing the left-hand side, just remember, if you see a positive number for x, you really need to transfer it to the equation as a -3. It's really moving it 3 units to the right. I see a -5 for y, which is moving it 5 units down. Remember, even though it's -5 here, when we go to the equation, it's going to be -5, which is +5. So you have to switch the signs. Okay. Number 4, write the equation of a circle with center at the origin. So remember, origin is 0, 0. That's our nice, easy case where we just have x squared plus y squared equals, you got to be careful here. They didn't say radius of 18 pi. They said a circumference of 18 pi. We need the radius in order to get the radius squared in the equation. Remember, your circumference formula is 2 pi r, and they're telling us that that circumference, that distance around the circle, is 18 pi. Notice there's a pi on both sides, so we can cancel out pi. We get 2r equals 18, so in other words, the radius is 9, which means the radius squared would be 81. So this is just a circle centered at the origin with a radius of 9. Another thing they might ask you to do is graph a circle. If they ask you to graph a circle, the radius will be nice and easy. It'll be a nice whole number. All you need to graph a circle is you just need to know the radius and you need to know the center. So for this one here, I'm just going to write off to the side, what's my radius? Remember, the 25 is the radius squared, so we need to square root that. Square root of 25 would be 5. And the center of the circle, next to x, I see plus 2. Remember, that really means it's moving left 2. So the x-coordinate of the center would be negative 2. And I see minus 4 next to y. So it's going to go up 4, opposite of what we would expect. So it's going to go negative 2, positive 4. I'm going to plot that on the graph. So remember, that's going left 2 units from the origin. And then it's going up 1, 2, 3, and 4. So there's my center plotted in quadrant 2. And then it's pretty nice and simple. You just need 4 more points for the circle. The easiest directions to plot are up, down, left, and right. So I'm going to do these in a different color. From the center, remember, what's a radius? A radius is the distance from the center to any point on the circle. Well, the easiest 4 points to use would be a point to the right of the center, a point above the center, a point to the left of the center, and a point below the center. That would be enough to create that round shape to connect the dots and make a nice circle. So I've got my red dot in the middle. Maybe let me keep the theme going here. There's my red dot. And now I'm going to plot my green dots. So from the center, I'm going to go 5 units because my radius is 5. I'm going to go 5 units to the right. 1, 2, 3, 4, 5. Go back to the red dot. Since that's the center, I'm going to go 5 units down. 1, 2, 3, 4, 5. Go back to the center. I'm going to go 5 units left. 1, 2, 3, 4, 5. Go back to the center. Last one, I'm going to go up. 1, 2, 3, 4, 5. And double check your counting. It's easy to miss a square. And I'm feeling like using blue to connect the dots. This is always the part. Do it quick, do it slowly so you can try to make the circle as round as you can. It takes a little practice. I will not judge the roundness of your circles as long as you're trying. Okay, I had it going pretty well, and then so that's all you do. You just connect those green dots together, and there's our circle, right? We can see centered at negative 2, 4, and each, we counted 5 squares right, 5 squares up, 5 squares left, and 5 squares down. So that guarantees that the radius is 5. Okay, number 6. And again, I'm going to write that nice structure for our equation of a circle in standard form. X minus h squared plus y minus k squared equals r squared. So in number 6, now it gets a little more interesting. They're going to ask us to write the equation of the circle with a center at 1, negative 3. Remember, that's your h and your k in the equation. That passes through the point 2, 2. So when they say that the circle passes through the point 2, 2, they're telling you that 2, 2 is on the circle. Remember, meaning on the circumference, on the round part. Well, remember back from the first page that we talked about, the point that's on the circle is xy. So the point that they're giving us is the x and y coordinate, and the center that they're giving us is the h and k coordinate. You'll notice in this problem they didn't give us the radius. So we can actually solve for the radius. And actually, you'll see we're really only going to have to solve for r squared, since that's what we need in the equation. We don't even care what the radius is here. They didn't ask for that. So I'm just going to set up my template first with plugging in the center. Okay, that's usually step 1, is I'm just going to plug in 1 and negative 3. Remember, I'm going to flip my signs, so I get x minus 1 squared plus, I see negative 3, so when I transfer it to the equation, it's going to be y minus negative 3, so y plus 3. Don't forget to square it. Equals, they did not tell us the radius, so we're going to just leave it as r squared for now. Our goal is going to be to find r squared. Okay. Always helps to go into the problem with a plan for what we're trying to find. Okay, well, what do I do from here? Well, I still haven't used the 2, 2. This is the point that's on the circle. I'm going to highlight that. So remember, that's your x and y. So in for x, I'm going to plug in 2, and in for y, I'm going to plug in 2. When we write the final answer for the equation of the circle, we're not going to have 2 and 2 there, but we have to plug in that point now in order to solve for r squared. So x is 2, y is 2. I'm going to transfer the rest of the stuff down in red again. To get 2 minus 1 squared plus 2 plus 3 squared equals r squared. And honestly, you could type that into your calculator on the left-hand side just like you see it if you don't want to do it by hand. This one I think is easy enough to do by hand, so I'm going to do that. 2 minus 1 is 1, so 1 squared, plus 2 plus 3 is 5 squared, which is r squared. 1 plus 25 would be 26 for r squared. And remember, we don't need the radius for the equation, we need the radius squared. If they ask for the radius, it would be rad 26. But we can actually stop here. We have everything we need. Last step is now I'm going to take that 26, I'm going to come back to step 1, and I'm just going to plug in 26 for the right-hand side. So my equation of the circle is x minus 1 squared plus y plus 3 squared. We solved for r squared, and we got 26. So radius is a little bigger than 5. Some decimal. Okay. Pause video for a second. Try this one out. Okay. And then I will, once you're done, you can unpause and check your answer. I'm going to write up here. Okay. Okay, so for this one, we've got a center at negative 1, 6. That's our h, that's our k. Passes through the point 4, negative 2. Remember, the point it passes through means it's on the circle. That's x, that's y. I'm going to start by setting up my template. We know we need to get r squared. We'll plug in x and y after we plug in the center. Let's set up the template so far. X coordinate of the center is negative 1, so it's going left 1. Opposite of negative 1 would be positive 1. Switch that sign. We have a positive 6 for y, so it's going up 6. I see positive 6. When I bring it down to the equation, I need negative 6. So there's my equation so far. And then in order to solve for r squared, I need to plug in 4 for x, and I need to plug in negative 2. See if my highlighter tool works here. I'm going to plug in negative 2 for y. Okay, so we get 4 plus 1 squared plus y is negative 2 minus 6 squared equals r squared. And we get 5 squared plus negative 2 minus 6 is negative 8 squared. Make sure you've got parentheses around that part, especially if you're putting it in the calculator, because if you don't put parentheses around the negative 8, it's going to tell you that negative 8 squared is negative 64. But we know that if you square a positive or a negative number, you get a positive. So we want to make sure we have parentheses around that negative 8. So we get 25 plus 64 equals r squared. 64 plus 25 would be 89. Okay. And I'm not done yet because they didn't ask me what's the radius squared. They asked me what's the equation of the circle. So now my last step, don't forget, go back to blue here for a minute. I'm going to take that 89 and I'm going to plug it back in for the right-hand side to write my final answer. So my final answer would be x plus 1 squared plus y minus 6 squared equals 89. Okay. Notice below we've got some great new iPhone models. If you're looking for maybe a new phone over the summer, you got the iPhone X, right? Because looks like it's vertical. Remember, vertical lines start with X equals. We got the iPhone Y, nice horizontal looking phone, right? Horizontal lines start with Y equals. And this one's really new. I think maybe coming out on I don't know, maybe May 25th. I can't remember, but I know this is the 2026 model. This is the x minus h squared plus y minus k squared equals r squared model of the iPhone. Look at that circular phone. Okay, pretty cool stuff. LOL. Okay. I'm done. Don't worry. All right, last one. Writing equations of circles given endpoints. So let's say they give us the endpoints of the diameter of the circle. Okay, so a little visual. Here's my circle. Let's just say this is my diameter. Okay. Well, in order to write the equation of that circle, I need a radius and I need the center. Remember, that's what you need for any equation of a circle is you need the center and you need the radius. The problem is if they give you the endpoints of a diameter, they're not giving you the center and they're not giving you the radius. They're making you work for it. You got to do a little bit of work in order to get there. First thing you want to do when you're doing a problem like this is you want to get the center. If you have the endpoints of the diameter, remember that the center is exactly halfway between those endpoints because you have those two radii that make up that full diameter. Well, that means that the center, I'm going to call it C, is the midpoint of that diameter AB. So to get the center of the circle, okay, they told us the endpoints are at A and B, 3, 0, and 7, 6. To get the center of the circle, I'm going to call that C, I need the midpoint of segment AB. Okay, and for that we need to remember our midpoint formula. Midpoint of a circle, midpoint of any segment, I'm going to put it at the top as a reminder, it's x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. We're averaging the two x coordinates, we're averaging the two y coordinates. So for my left endpoint, I'm going to label those x1, y1. My right endpoint, I'm going to label x2, y2. And I'm going to calculate the center. I'm going to add the x coordinates, 3 plus 7. I'm going to divide that by 2. And then 0 plus 6. Remember, we're adding them, not subtracting them. 0 plus 6 divided by 2. 7 plus 3 would be 10. 10 divided by 2 is 5. 6 plus 0 is 6. 6 divided by 2 is 3. So now I've got my center of my circle, which is at 5, 3. So this is my H, this is my K. And the graph here is optional. For this first example, I'm at least going to graph it so you can kind of see what's going on. As long as you remember the steps of using the midpoint formula to get the center, and then I'll show you how to get the radius. You really don't need the picture, but it is nice to see what you're actually calculating. It's not just a whole bunch of random arithmetic. There is a process to this. So what we have is we have the centers at 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. Okay, there's C. And they gave us the points 3, 0, and I'm going to do those in green. 3, 0. There's A. And 7, 6. 5, 6, 7. 1, 2, 3, 4, 5. Okay, there's B. Okay. And so, now we know that that's going to create the full diameter of the circle. So now we've got the center, which is helpful. Okay. And so, if I kind of estimate here, if I was to graph this whole circle, it looks like it was probably about that long. I don't know exactly what that radius is yet. It's hard to count when it's on a diagonal, so I'm going to have to do a little bit of work, but at least I can estimate what this circle would look like. I'm going to add 2 more points in orange here, and then connect the dots. This would probably be a rough estimate for what my circle looks like. Okay, well, I did okay on that side. Okay, not too bad. So that's kind of, we're getting closer here. So what do we need? So, right now what we have is H and K. We've got that the center here is at 5, 3. Now we just need the radius, and then we can write the equation of the circle. So I'm actually first just going to set up my template for what I have so far. So far what I've got, I'm going to set up my little x squared plus y squared. We don't have r squared yet, so we're going to have to do that. We do know, though, H and K. We know that H is 5. Whoa, that highlighted quite a bit. Get rid of that. H is 5, so I'm going to put minus 5 in this first spot next to x. I got to switch that sign. And then we've got a positive 3. It did it again. Let's get rid of that. I see positive 3. So I'm going to put, whoa, man, it really has a mind of its own today. I'm going to put a minus 3 next to y, switch those signs. Okay, so I've got positive 5 transfers to minus 5, positive 3 transfers to minus 3. Okay, and now, here's the thing. We're going to do exactly what we did in the last two examples. We're going to plug in a point that's on the circle, a point that the circle passes through. What's that? That's going to be x and y. We need to plug in numbers for x and y to help us figure out what r squared is. Well, what do we plug in for x and y? Well, it has to be an ordered pair that's on the circle. Here's the thing. In this problem, you actually have the choice of using one of two different points. You've got point A that's on the circle. Those endpoints of the diameter are your two choices. And you've got point B is on the circle. I'm going to label those. So here we've got 3, 0. And here at B we've got 7, 6. So you can use whichever one you want. Both of those are points that are on the circle. They're on that red circumference that I drew, the round part of that circle. Doesn't matter which one you use. You can try it both ways for practice. I always say pick the point that looks like it has easier numbers. Easier to me, it would be less negative signs, smaller numbers, nothing with really, really big numbers like 10, 11, 12, things that look easy to plug in so that you have the quicker arithmetic for yourself. I personally think in this one 3, 0 looks easier than, I think 3, 0 looks easier than 7, 6. Anytime there's a 0, that just usually makes life easier. So I'm going to choose to plug in 3 for x, and then I therefore have to plug in 0 for y. Again, I could have plugged in 7 for x and 6 for y. I'm going to get the exact same value of r squared. All right, so we've got 3, bring the minus 5 down, bring the square down, plus 0 minus 3 squared equals r squared. Okay. This one I am going to do in the calculator just to show you. So we got 3 minus 5 squared. I'm going to open parenthesis, 3 minus 5, close parenthesis, hit the x squared button, plus, open parenthesis again, so I'm typing it just like I'm writing it, 0 minus 3. Remember, the minus sign, the subtraction is the right column. You don't want to use the negative sign in the bottom row. This one in the right column is reserved for subtraction. 0 minus 3, close parenthesis, squared. Looks like we've got 13. Perfect. So there's our r squared, would be 13. Okay. So at this point, I could write the equation of the circle. I think I'm actually going to pause for a second and do that before I answer the question. Because I need r squared for the equation, right? It's x minus h squared plus y minus k squared equals r squared. Well, I've got everything I need now. So I'm going to go back, just like we did in the last two examples. Looks like it froze. Hang on, let's see here. Woo! Oh no. Something happened. There we go. And I'm going to go back. Okay, something happened here. There we go. Having a little tough time here for a minute. I don't know what's going on. Well, let me try writing with my finger. It should work. So we've got, let's see, x. Nope. Okay, you know what? Looks like the battery might need to charge for a minute. Maybe take a pause for me on the video and see if you can write the equation while my pen charges. Alright, let's see if that did the trick. There we go. We're back. These pens have a small lifespan. Okay, so we've got x minus 5 squared plus y minus 3 squared. And then remember, we just need to plug that 13 in for r squared. So there's my equation of the circle. They did in part B ask for the radius, so I am going to make sure I square root both sides. R squared is 13, so the radius would be root 13 does not break down. So there's my radius. And if you kind of see, it looks like, let's see, root 13 is about, root 16 would be 4, so root 13 is a little smaller than 4, 3.6. So those blue segments that I drew on the graph, they're about 3.6 units long. Okay. All right, there's another one for you to try on the bottom, and I will post this one on my key if you want to see this one. Go through the steps again. Again, finding the center, you're going to use the midpoint formula. You're going to find the midpoint of A and B. To find the radius, you're going to use either A or B to plug in for x and y to get that radius squared. From there, you can get the equation of your circle, and you can square root to get your radius. So again, this one's going to be on my 12.5 notes key that I will make sure I post on Google Classroom for you. Give this one a try. The graph is totally optional at this point. You've kind of seen the steps, so if you feel like the graph helps, great, but you really don't need the graph in this case. Okay? All right. Happy mathing.